Hello, Algebra team. I wanted to do a quick video on this concept of systems of equations. Notice we have two linear equations here. These are both linear equations because there's a single, the x is raised to the first power, and we have an x and a y. So these are just two lines. These are just lines. They're linear equations that make lines. And the solution, when we talk about what is the solution to these things, what is the solution? That is simply its point of intersection, where there is an x-coordinate and a y-coordinate that sits on both lines. Now, in some cases, we'll see it could be lots of points, but in most cases with lines, if you think about it, lines intersect. When they intersect at a single point. And so what we're doing is we're trying to find what that single point is, and that is our solution to the system of equations. Okay? And so since these are just lines, an easy way to find the solution is to simply graph it. And I've done that in Desmos. Let's take a look. So if we go over to Desmos, you'll see that I've actually already plugged in the values, the linear equations, 4x plus 2y equals 6 at the top, and then 6x plus 2y equals negative 6 is the bottom one. And you see it creates the two lines here in the graph. And if we just look at their point of intersection, we see the answer is the x-coordinate is at negative 6, and the y-coordinate is 15. So the x-coordinate is negative 6, and the y-coordinate is 15. So that's x equals negative 6 and y equals 15. And that's our answer. This is the answer to the solution for these linear equations. But how would I solve this if I didn't want to graph it? Is there another way to solve it? Can I solve it algebraically, we say? And the answer is certainly we can. But what we want to do is, let me make some room up here. What we want to do is we want to do this by addition. We're going to combine and add these two equations together such that we can reduce one of the variables, make one of the variables go completely away, go to 0, and then we only have one variable that we can easily solve for. And then once we have that, we can plug back into the original equation. So let's see how that works. So if we look at this equation, we say, what do we want to do to get rid of the y's? Let's say we want to get rid of the y variable. Let's say we look at the y variables and we have a 2y and a 2y. If we want to get rid of it, we can make one of them a negative 2y. And when we add them together, they'll go to 0. So to do that, we can multiply this entire equation by a negative 1. If we do that down here, and I'm going to do it in red again, we're going to have a negative 6x minus 2y equals 6. And our top equation, if it stays the same, 4x plus 2y equals 6. And then we can add these two guys together. You'll see that we end up with a negative 2x. The y terms go away, and we did that on purpose. And then equals, add these two together, you get 12. So x equals, not surprisingly, negative 6, just like we saw over here. Now, how do we find y? Well, we take our x equals negative 6, and we plug it back into one of the original equations. So let's do that. 4 times negative 6 plus 2y equals 6. Well, that's negative 24 plus 2y equals 6. 2y then equals, add 24 to both sides, and you get 30. Y equals 15. It checks out. Our algebraic solution matches our solution that we did by graphing. So again, to recap really quickly, all we did is we said, what do we need to multiply one of these equations by so that one of these two variables will go away? We chose picking the y to go away, to go to 0, because it's easiest. We just multiply through by negative 1. And really what we're doing on the top equation is we're just multiplying it through by 1, but it stays the same when we do that. Okay, so I hope that's helpful.